What if I told you the story of dinosaur extinction is a lie? Well, sort of. An asteroid definitely hit 66 million years ago, but it didn't wipe them all out. Not even close. In fact, you probably see their descendants every single day. We're going to follow a trail of fossil clues that connects the terrifying T-Rex to, of all things, the chicken. We'll piece together a story left behind in stone for millions of years, revealing one of the most incredible truths in the history of life on Earth: we're still living in the age of dinosaurs. For a long time, connecting birds to dinosaurs was just a wild idea. The first real clue dropped in 1861, just 2 years after Charles Darwin published On the Origin of Species. It started with a single fossilized feather found in a German quarry. A few months later, that same quarry produced a nearly complete skeleton of a creature about the size of a crow. They called it Archaeopteryx, or ancient wing. At first glance, it looked like a bird. It had wings and feathers that looked surprisingly modern. But a closer look revealed a bizarre mix of features: a mouth full of sharp teeth, 3 claws on each wing, and a long, bony tail. This was no ordinary bird, it was part reptile. The discovery sent shockwaves through the scientific world. Was this the missing link that Darwin's theory predicted? A transitional fossil caught in the evolutionary act? Still, the flight capability of Archaeopteryx is debated. With a relatively flat sternum, it likely wasn't a strong, powered flyer like modern birds, and its feathers might have been used more for insulation or gliding. For over a century, Archaeopteryx was this lonely, mysterious fossil. The case was compelling, but it was far from closed. To really crack this mystery, paleontologists needed more evidence. And they'd find it, decades later, on the other side of the world. The plot got a whole lot thicker in the 1960s with the discovery of a dinosaur in North America called Deinonychus. This wasn't a slow, lumbering giant. It was a fast, agile predator, and its skeleton was startlingly similar to Archaeopteryx. This discovery kicked off the dinosaur renaissance, a revolution that completely changed how we see these animals. Scientists started zeroing in on a group of two-legged, mostly carnivorous dinosaurs called theropods, a group that includes everything from the clever velociraptor to the king himself, T-Rex. Once paleontologists began comparing theropod skeletons to birds, the similarities were just undeniable. Let's talk about the wishbone. That V-shaped bone you might find in a Thanksgiving turkey is called a furcula. It was long thought to be unique to birds, acting like a spring during flight. But then, paleontologists started finding furculas in theropods like Velociraptor and even T-Rex. The connections didn't stop there. Birds are famous for their lightweight, hollow bones, an adaptation that makes flight possible. Guess who else had hollow, air-filled bones? You guessed it, theropod dinosaurs. We also see it in their wrists. Birds have a specific half-moon-shaped bone that lets them fold their wings. That exact bone is found in theropods like Deinonychus. Bird embryos even start developing 5 fingers that later fuse into the 3-fingered wing, mirroring the hands of their theropod ancestors. From their feet and ankles to their egg-laying and brooding behaviors, the list of shared traits just kept growing. The skeletal evidence was overwhelming. Birds didn't just resemble theropods, they were built from the exact same blueprint. They are, in a very real sense, a specialized branch of theropod dinosaurs. Despite the mountain of skeletal evidence, one huge question lingered: what about the feathers? For the longest time, Archaeopteryx was the only dinosaur-like fossil with them. If birds really were dinosaurs, where were all the other feathered fossils? The answer exploded out of Liaoning, China in the 1990s. Ancient lakebeds there began yielding an incredible trove of fossils so well preserved they included soft tissues, and the unmistakable outlines of feathers. There was Sinosauropteryx, a small theropod covered in simple, hair-like protofeathers. There was Caudipteryx, with more complex feathers on its arms and tail. And then came mind-blowing discoveries like Microraptor, a four-winged dinosaur with long flight feathers on both its arms and its legs. These fossils proved that feathers weren't unique to birds. They were common among dinosaurs. This raised a new, fascinating question: what were all these feathers for? Most of these dinosaurs couldn't fly. Their feathers were too simple, or their bodies were too big. It turns out, feathers probably didn't evolve for flight at all, at least, not at first. The simple filaments on Sinosauropteryx would have been perfect for insulation, keeping these active animals warm, like the down on a baby chick. Other feathers were for showing off. The fossil of Kaihongjuji, a duck-sized Jurassic dinosaur, showed evidence of iridescent, rainbow-colored feathers. These were likely used to attract mates or scare off rivals, just like a modern peacock's tail. So, feathers first evolved for warmth and communication. Only later were they co-opted for flight. This neatly explains the old "what use is half a wing" puzzle. Feathers weren't an early attempt at a wing, they were an evolutionary happy accident. An existing feature that gave some smaller dinosaurs a little lift, kicking off the whole journey toward flight. Some may have started by gliding down from trees, which the anatomy of Microraptor supports. This led to a wild period of experimentation, with some dinosaurs developing four wings, until finally, the ancestors of modern birds perfected powered flight. Now, in the spirit of good science, we have to say, not everyone is on board with this idea. The consensus is huge, but a small number of scientists still challenge the bird-dinosaur link. Some researchers, like ornithologist Alan Feducia, argue that the similarities could be due to convergent evolution, where two separate groups independently evolve similar traits. They point to things like the temporal paradox, the fact that fossils of super bird-like dinosaurs such as Velociraptor are actually younger than the first known bird, Archaeopteryx. It's a fair critique, and it forces paleontologists to constantly test their ideas. However, the mainstream view is that this paradox doesn't disprove the connection. Just because we haven't found a Velociraptor ancestor that's older than Archaeopteryx doesn't mean one didn't exist, it just means we haven't found that fossil yet. The fossil record is famously full of holes, and every year, new discoveries of older, bird-like dinosaurs help close those gaps. While the debate keeps the science honest, the mountain of evidence points overwhelmingly in one direction. Modern science has even brought new lines of evidence, like watching bird embryos briefly develop ancient traits like a long tail or tooth buds, which are then lost before hatching. It's like watching evolution on fast-forward inside an egg. So, while some may still contest the classification, for the vast majority of scientists the conclusion is clear: birds aren't just descended from dinosaurs. They are dinosaurs, the single surviving lineage of a once magnificent group. This whole story is a perfect example of science at its best, a detective story that took more than 150 years to solve, with clues buried in stone. Each fossil, from the first feather of Archaeopteryx to the rainbow plumage of Kaihong, added a vital piece to the puzzle. And it has completely rewritten our vision of the past. Dinosaurs weren't all scaly, green monsters. They were dynamic, complex animals, many of them covered in a wild array of feathers, doing things we see birds in our own backyards do today. So the next time you see a pigeon on the sidewalk, a sparrow in a tree, or hear a chicken clucking, just pause for a second. You're not just looking at a bird. You're looking at a modern-day dinosaur. You're seeing the last survivors of an incredible evolutionary dynasty, a living, breathing connection to a lost world. The terrible lizards never really vanished. They just learned to fly. If you enjoyed this, consider subscribing and hitting that notification bell. And for your next video, check out our one on what would have happened if the dinosaurs never went extinct. Thanks for watching.